first video in a series of videos that will walk you through how to use your Raspberry Pi to interface with the outside world. This video will focus on setting up your circuit on your breadboard in preparation to control it with your Raspberry Pi. This is a fantastic first project in using the Raspberry Pi's GPIO pins because it's easy to create and easy to code thanks to Python's GPIO modules. For this video, you will need your Raspberry Pi and access to the GPIO pins. Next, you will need your breadboard with your Pi cobbler installed. The Pi cobbler is great because it takes the guesswork out of pin numbers and makes every pin available for prototyping on your breadboard through the handy patch cable. We need a 220 ohm resistor so we don't saturate our LED with too much current. Saturate is the technical term for burning it out. We don't want that. We will also need 2 jumper wires. Black and red are preferable to keep your positive and negative separate. Lastly, you will need an LED for this project. I chose blue. With these materials, you are making something happen in the physical world that you wrote through code. Pretty cool, huh? Let's get started. First, we grab our LED. Remember, an LED has a long wire, and this is our positive. This is important to get right, or it won't work, and you'll be sad. Take your breadboard and insert your LED with the anode in row 24 and the cathode in row 25. For this example, I'll be placing them both into column F. Take your 220 ohm resistor, denoted by the orange-brown bands, and bend the wires to make a U. Insert one wire into row 25 and the other into row 30. Now we take our red jumper wire and connect our 3.3 volt pin, named 3V3 on the cobbler, row 9 on our breadboard. We take the other end of our wire and we connect it to row 24. Lastly, we take our black wire and insert one end into row 30 and the other end into the ground pin on the cobbler. Grounds are special because it doesn't matter which one you use. They're all linked. Usually we choose the one that is the most convenient for us to use at the time. Here's what our circuit should look like now so far. And now we're ready to test it. Our next step is to connect our Raspberry Pi to our breadboard with the patch cable. If you have your Pi powered on, you should turn it off at this point. Plugging in the patch cable could short things out if your wiring is wrong. First, we're going to plug in our cobbler. Then, we'll plug in our Pi. Make sure the cable goes towards the middle. This is the correct way, otherwise it won't work. Now, let's power on our Pi. Your LED should come on, which means your circuit works. If it doesn't, trace back the steps and make sure you have everything plugged into the right spots. Now we can unplug our Pi again. Now that we know that our circuit is functioning correctly, we need to get it ready to receive a signal from the Pi. To do this, we pick one of the pin numbers that we're going to turn on through our code. So we will move our red jumper wire from row 9, which is our 3.3 volt, to row 11 on the other side. If you look closely on the cobbler, it's number 25. Now, we power our Pi back on. Nothing should come on. Not yet. So that's it. During this video, we wired our circuit into our Pi cobbler, so the Raspberry Pi can turn on our LED. The next step is to write the code to make our LED turn on and then off again. Maybe even blink a few times. In the next video, we'll be scripting our code on the Raspberry Pi and experimenting with a few different circuits. So until next time, keep making!